Hello and welcome back to our series where we are building an employee success predictor. This series is brought to you by Prairie HR Solutions. My name is Jake Finger, founder and principal consultant of Prairie HR Solutions. And in this video, I'd like to carry on with where we left off and finish this thing up. Now, this is built in Google Apps Script using data from a Google Sheet, and it's using machine learning principles and concepts, but it's going to be limited simply because AppScript is not built to do what it is that we're trying to do, but it's going to work great as a prototype. And the reason why we're going to run into issues is when you're trying to teach a model and determine the correlation between a whole lot of data sets that we would typically find within a employee record of performance and competency evals and things like that. Google Apps Script just isn't built to run those calculations for that long of a time. It's not a mathematical based, it's a web based. So we can only use it up to a point, and then we're going to have to migrate this to Python. Now, we've chose to do this in Google Apps Script because we already had a series started on Google Apps Script. We're building a PCM in another series, People and Culture Management System. And this is just naturally going to fall into that, particularly in the functionality of an employee career path tool. So we're starting in Google Apps Script. More than likely, it will be migrating to probably Python is what we'll use. But the intent is for a manager or someone, HR, whoever, to select an employee ID, say number 8, and then select a given task, we'll say task A, and then press a button to get the probability of success. Now, the reason why it says null is because we don't have a function to actually find that yet. And that's what we're wanting to do here in this particular episode to finish this thing up. Now, this thing is not going to be a one and done. We only have 9 data points, and we're going to need probably hundreds in order for this percentage to be valid and actionable. But at least we'll have the functionality, the base function to scale upwards as we build our database for an employee career path as well as performance management. So now let's jump over to our Google Apps Script, which is where we left off. And where we were was we created ourselves a little hint here, a little to-do list comment. And that's really where I want us to pick up at. We need to create a function that will return our probability. And in order to do that, what we're going to do is create a variable, which will call that function and then pass information to it and then return that variable value at that time. So what I mean by that is we have our employee data object built from our for statement here, our for loop. And we also have this selected task that we haven't done anything with, but that's where we're going to pass. We're going to pass our employee data and our selected task to a function that is designed to specifically calculate our probability. So let's finish this up. And we'll create a variable. Let's just call that variable probability. And what that probability variable is going to do is call a function and then store whatever is returned from that function in this variable and then return that over to our HTML side, our JavaScript. So we need to create a function, and let's just call this function calculate probability. And what this probability is going to accept and receive and send over is our employee data, which is now a full object, as well as the selected task. And then when it gets done running this and stores it in the variable, then we just simply want to return that over to our JavaScript side. Like so. So now what we need to do is create this calculate probability formula. And you'll notice that I did the same exact thing. If you were watching the other two videos, I did the same exact thing here. I've shown the correlation formula, which is what we built for our correlation function. And I did the same thing for our weighted sum as well as our logistic regression formula, which will provide our probability. Now, the idea is to use Google Apps Script and JavaScript and this data to create these variables and then write the calculation to have it run. Now, this isn't going to be a statistical tutorial, so we're not really going to go in depth about weighted sums and all that and Euler's number, because the intent is not to teach you the statistics behind it per se, but rather provide you with a function and why that function works and what it's doing. So then you can scale it to meet whatever need it is that you're wanting to meet. So let's go ahead and create this function here. And this function is called calculate probability. And that is going to take our employee data and our selected task. Now these aren't going to change. So we're not doing this for X and we're not doing this for Y like we did with our matrix. So we can just keep it simple and use the same terms. And what we're going to need to do is define our coefficients, essentially define the weights as they relate to our headers. So we need to take our headers and give a weight to those values. So let's create a variable and let's just call it coefficients. Should I spell that right? Yep. And this coefficients is going to be in the form of an object with key value pairs. Now the first one that we're going to do is, let's just grab these so we don't have to keep going back and forth. Take these and put this up here. So it's going to be, the first one we're going to do is this current role tenure years. Now remember, since we're using the headers as anchors essentially, we must make sure that these are exactly the same. If we used underscores in the code, the sheet needs underscores and vice versa. So now what this is going to do is, what we're going to assign, the value that we're going to assign to this key is how much weight we are wanting to give this current role tenure years value. And what the weight does is it goes through and uses that weight to determine if one value is more important than the other. Now we're doing this manually and we only have 9 data points. So there's going to be a little bit of fishing, I suppose, that would need to go through this. And if you were doing this in real life without a dedicated library to kind of determine these weights mathematically, then it's going to take a little bit of hit and then check, hit and then check. And that's fine for what we're doing right now. But once we migrate this over, we'll actually use a library to take all of our data and then find the weights in a more mathematical number. Now the weights are essentially negative and positive. 0 is obviously, 0, 0.5 is, obviously 0.5, 0.1, 0.3. So when I'm writing these out, I'll try to explain what the rationale is behind 0.1, which is going to be our first weight. So our first weight for current role tenure years, we have at 0.1. Well, we're not going to put it as 1 because that means that it is, absolutely important. But we do want to ensure that it is given some weight. But current role and tenure years, the way that we're thinking about this, and this is fictitious data, but the thinking is the same. After studying this, we determined that just because an employee is inside their current role doesn't necessarily mean absolute success. So if they've been in for 8 years, it doesn't mean that they're going to be more successful than somebody in 2 years. It's important, but it's not a major deciding make or break factor. So we're going to give this a weight of 0.1. The next one is our company tenure years. And I'll do this one here and then I'll populate the rest of it just so you don't have to sit here and watch me type all this out. And this weight we would give, let's do a different one of 0.05. Now what we're saying is we have found in our company, the longer a person is, and this is fictitious data, obviously, but the longer a person is with the company, they tend to get somewhat complacent and slightly less productive. Now, this is, again, fictitious data, but that's the thinking behind that. We've noticed statistically, with data to back it up, that based on our company tenure, our success goes down. And a good way to get this, let's come back over here. And that is the idea behind this matrix here. Now this matrix is different because we have different headers and variables here, but that's kind of the idea. So if we were looking at company tenure, we would notice that we have like 0.2, 0.3, but here for training hours we have negative 4.1. So if we were to average all of these up and it matched our data and our employee data perfectly, we would get roughly negative 0.5, whatever, or 0.5. That's kind of the rationale behind this. So that's where this correlation matrix comes in handy. So I'm going to pause our video right here, and then I'm going to go through and write the rest of these, and then you'll see what it is that I'm actually talking about here. So let's pause this, and I'll see you in just a sec. Okay, so I've populated the rest of these, and just through running some confidence tests on these models, just with the 9 that we have, well, a little bit more than 9 now that we have our behavioral competencies in here. You can see that some of these are 0.1, 0.5, 0.3, and without a library, this is going to be hit or miss because you're going to have to run it, you're going to have to test it, and you're going to have to make sure that it's valid. When you have a larger data set, you're able to do that mathematically, confidently, but we don't have enough data to really run that through there yet. So we just have data in here to be functional. So what this is saying is we already covered our company tenure. The longer people are there, we tend to find that they're slightly less productive. We just see that trend going down. And then this intercept, we're setting at negative 2.0. And what we're calling this intercept is essentially, this piece right here, like this and that on our correlation matrix. So we're finding out that our average intercept here comes out to, negative 2.0. Now, if you find yourself, because we only have a little bit of data in here, if you find yourself when you're running this, that you are always getting 100%, 99.9%, it seems like every employee is successful or every employee is failing, your weights need to be adjusted. And if you're doing this without a library, then again, that's going to consist of changing a weight based on data that you have and then running a test on that and then seeing if that's actually what happens in real life or you're missing something. That's why they create libraries like this, because if you think of what I just said, there are a lot of variables that you're going to be picking up along the way, and this is going to be exponentially longer than just 2 years, 3 years. It's going to be a lot of work. So if you can just get all the variables isolated, run it through a library, then it will find these for you. And who knows, maybe if we have bandwidth within Google Apps Script, maybe we can create a function to find these weights for us. But we have our weights, we have our items with our weights. So now what we can do is actually define how far each one of these variables can go. So we don't want our variables to go up to an infinite amount of numbers, because then one, it's going to slow down our code, but two, it's not going to necessarily be valid. We want to constrain it. So our company role, our company tenure in years, if we only have a person, our person with the highest tenure is 14, we don't want it to consider 15, 16, all the way up to 1,000. We don't want that. Same with the average performance score. We only want to give it, a range to kind of have it be a little bit more concise. So let's create ourselves a variable. Let's call that variable feature ranges. And the great thing about this, when you get this built, this can change dynamically. So what I'm going to do here is I'm going to take this, because they're going to be the same exact things, except it's not going to be the weight. It's going to be a range, and the range is going to be in the form of an array. And so our current role tenure in years has a minimum of 2 years and a maximum of 8 years. And what we can do is populate this. So I'll stop this and then populate this so you're not watching me type, and then constrict just how far out it's going. So it's going to look something like this right here. Okay, now this is, again, this is fictitious data, so this is somewhat arbitrary. I mean, there's a common sense element to it, but if we were doing this, in real practice, this would be a lot longer, and we would be a little bit more methodical about not only these weights, because we'd have to make sure that we can defend these if challenged, as well as these ranges here. Okay, good. So we have this. So now what we want to do, let's put a semicolon here. Now what we would like to do is get the task specific weights. And that's where, see where to go. That is where, oh, did we just delete it? Okay, yep, we just deleted it. So that is where we deleted it. That was where our previous piece was. So we'll have to change that here. Okay, so what we're going to need to do is get our task specific weights. So we'll just recreate these. And what our task specific weights are coming from is really two pieces. We have our selected task, but then we need to create the weights inherent to those tasks. So let's create a variable up here, just to be a global variable to where everyone can jump into that, or every function can jump into that. And let's call this tasks. And this is going to be a key value object as well. And we're going to first need our task A. That task A corresponds to our drop-down box task A. And then it's going to create, and then we're going to need to essentially grab these coefficients, change the weight specific to these tasks. Now, I want to just kind of stop and interject something here. A great source for these weights is actually already provided for us through a job analysis. I mean, because if you think about it, you can go through a job analysis, and if these are all, the technical competencies, behavioral competencies, you can drill this down into individual KSAOs as well, which would be ideal. Then the job analysis would contain all of these weights, and then through the job analysis or a grouping of job analysis, you can look at shared behavioral scores and then find the weights there. So it's not as cumbersome as you would think, unless, of course, we don't have job analysis. Then it can be kind of task heavy. And I'm going to leave C blank because we want to be able to see if it's returning null data or not. So let me grab this. And we're not wanting, obviously, task A isn't going to care about company tenure, average performance score, anything like that. What we're really looking at is these behavior and technical competencies. Because the task is made up of competencies and the KSAOs that go into those competencies. So that's really all we're looking at. I should probably just grab that. Could probably I'll go through and use those same ones, or make sure that our quotations are the same. Okay, so we have this, and now let's copy this and also put it right here, because now we're going to change our score. So let's say task A has a technical competency 1 that is incredibly high. It is a make or break competency. If you don't know how to do this, then that task is going to fail. So let's just create a comment here. Places high importance on this tech comp. And let's give that a 1.2. That means that this is absolutely important. And then this one here, let's just give it 1.0. And again, these are just arbitrary numbers because we're not actually doing this or have that built yet. And then task B, let's call this 1.0. It's not quite as much, but it's still pretty good. And then we'll call this 1.0. And then this is 1.0. And maybe this technical competency here is 1.2. So you see that overall, our technical competencies for these tasks are pretty important, and they're going to weigh heavier than our behavioral. So somebody could just rock this behavioral competency right here, or say right here, this one right here, but do very poorly here. And because this is weighted more, that's going to drive their percentage down. And that's really what we're wanting, right? We're wanting to take a look at all this. And then we'll leave task C empty, excuse me. So now what we can do is we can grab this selected task and then get these weights here in these tasks. Let's create a variable, and we'll store that in a variable. Let me save this just in case we lose internet or hiccup or something like that, and don't want to have to retype all this. Let's create a variable and call this task weights, I guess. Yeah, that would work. And what we're going to want to do is come up here and grab our tasks and then get the weights of those tasks. And then we'll assign those tasks to the appropriate line coefficients here. So we want to take our tasks, and then inside an array, we want to put in essentially for the tasks, we want to look at what the selected task is and then grab that object with all its key values. So to do that, we're going to need to know what selected task was passed to us. Now that that's stored in a variable, we can then check and run a for loop to grab those coefficients and the keys, and then adjust the coefficient weights based on the appropriate task weights. Because we don't want to change everything, we just want to change our competencies. So in order to do that, we should probably check to see if the task is even there. So if somebody tries to select task D, then we want to give it an error, letting them know that that task isn't found and we need to create it. So what we can do is just, if task weights does not exist, then we want to, let's do a console log, just in case we need to actually do some debugging here, and just simply return error, task not found. That way we'll know it's not reading it correctly. And we want to return also task not found. Okay, good. So that'll take care of the instance. If nothing happens, we'll be able to figure out why it didn't happen a little bit easier. Okay, so now we need to adjust. Let's create a comment here. Adjust weights based on task requirements. And that is what we put in our task variable up here. These are the requirements and weights. So to do that, we can simply just run a for loop. And this for loop is going to be a for in. So we will do let key in coefficients no, not coefficients, my mistake. This should be key in task weights, this one. My mistake on that one. Hope I didn't confuse you too much, because what we're trying to do is for every task weight here, every key, we're eventually going to grab the value for each one of these, and we're going to loop through that. And what we're going to want to check is if the coefficient at that key, so if this technical competency number 2 score doesn't equal undefined, then we want to do something. So we want to check to see if it's undefined first. And undefined means that it's not aligning, it's not found. So if the coefficients for every key does not equal undefined, because if it equals undefined, it's just not going to do anything. Then we want it to adjust the weights dynamically. We want it to go through and change essentially our coefficient values based on that key, that title there. And what we want to run is, there we go. What we're wanting to run is a compound operator with multiplication. So we've already seen this in action, which sums it, right? What we're going to want to do is a multiplication version of that compound to multiply everything together. That way we don't have to keep writing this out. So how this is going to look is, if it comes back not undefined, if it comes back undefined, it's not going to do anything. But if it doesn't come back undefined, we want to take the coefficient at every key and then run a multiplication compound operator on every task weight key. And what this is going to do is this is going to then take this base level here, and compound this onto that. That's what that's going to do. Because every employee is going to have this as a base, but they're going to need just a little bit more for task B, for instance, and we're going to need to compound this onto that. And that's what this multiplication compound operator is going to do. So let me write a comment here. And this is adjusting the weights dynamically based on the task data and requirements. There we go. And then, of course, if it does come back undefined, well, then it's just not going to do anything. Okay, we're going to need to close out that one. I think we got rid of yep. Okay, so now we have that. So now what we need to come back up and do is find our weighted sum. Start digging in here with this. So this is our weighted sum formula. And the reason why we're going to find our weighted sum is because we need to dig into, our feature ranges right here, as well as our intercept. So this, I'm not going to go too much in depth about this weighted sum, because again, it's not a statistical tutorial. It's the intent is to give you a function that when you need to find this weighted sum to find this logistic regression, you'll have that function to do just that. So the way that this is going to look is, let's calculate, oops, let me spell that right for y'all. Calculate weighted sum. We're going to need to store this in a variable. So let's just call this variable weighted sum. And that variable, we're going to use the same exact thing just like this. That variable is going to be equal to the coefficient at our intercept. So this minus 2.0. And then we're going to run essentially another for if statement. And we're also going to apply some scaling to it. And what we're going to need to do with this scaling, the scaling itself, we're going to leave this off and see how it returns. We may need to confine it a little bit more. But we'll see how it goes, because if we're getting things way off and everybody is just succeeding or failing, then that means that typically our weights are off, and then the scales that we have are off for those little pieces of data points that we do have. But we'll try it without it. So let's just jump in here with this. So let's do another for in loop, for key in. So let's do this for. We'll let key in. Now this time it's going to be the coefficients. And if the key does not equal intercept, because we don't want to count it if it equals intercept, and we need to check another condition, and that is if the employee data at every key does not equal undefined. Now, undefined is actually returned as not a string. Undefined will come back as undefined. It's actually a value that's going to be returned. So See, if the key does not equal intercept, so if it doesn't equal that intercept piece here, so all of this, and the employee key isn't undefined, which means it exists, then we want to apply some scaling here. And that is where our scales are coming into, right here. We are confining it. So we need to grab this featured ranges. Let's do apply. Let's just do scaling if necessary. There we go. And we'll say let min is going to be equal to our feature ranges at key 0. Because remember, this is a variable, or not a variable, this is an array, and this is the 0 index, this is the 1 index, so that's the min. And then the max is going to equal feature ranges for every key at index 1. And then we'll want to create another variable called scaled value. And that is going to be equal to our employee data at every key minus the min divided by value weight. Okay, so divided by simply max and min. Max minus min. All right, good. So there we go. There's that. And then what we're going to want to do is incrementally take our weighted sum and sum that with the coefficients for every key multiplied by this scaled value. And that should give us, as you can see, the summing right here. So we need to incrementally sum it, and then that should be able to, that should give us our weighted sum, or Z, and our probability formula here. So let's add another line here, and this is going to be weighted sum, compound operator there, and that's going to be our, see, where is that, coefficients at every key multiplied by our scaled value. Okay, there we go. So that should take care. Let's make sure that we got our closing brackets. That's good for that for loop. This should still be our main function, and it is. So now let's create a console log here just to help with some debugging, just in case we need it. And what we can simply put in here is weighted sum for employee, and we'll do something like this, task such and such. Now, what in the world do we have going on here? No, I guess that's right. Just looks weird. The selected task plus that, get rid of that, that, and then plus weighted sum. Okay, so if there's an error or we need to find something, we can pull open that F12 and then just look at this console log here. Okay, so now we have everything that we need let's make sure we have everything we need for this logistic regression formula. We have our weighted sum. E is RU, yep, we have that. 1 and 1. Okay, so yeah, we have this. This just needs to be negative. Okay. So let's come down here and let's do that. Let's apply logistic function. We'll put that in a variable here. That'll be that probability variable. So remember, probability is actually going to be returned right here. That's what we're wanting. Okay, so our probability variable is going to equal, let me make sure I get this right here. 1 divided by, it's going to be 1 divided by, now we're going to need to find the exponent of our negative weighted sum. So let's do 1 plus math.exponent negative weighted sum. And then we want to return that as a percentage, because right now that's just going to give us a number, but let's return that as a percentage, which will be probability times 100. And this percentage is just going to go out like crazy if we don't stop it. So let's do a 2 fixed, and let's just give it 2 variables. And then we'll also add, since we're just writing it in that P statement, we'll just give it a percent sign. Okay, so I think we have this. So let's save this and see what we got. We'll pull up F12 because I'm sure we have something that is a little bit missed. Because anytime that we do this, we wrote a lot of code here. So let's just see how this works. We'll save it. We'll refresh this. It saved fine, so there's no errors there. And let's just pick 18 and we'll do task A. We'll get the probability. See what it produces here. Okay, so our task is not found. Task B. So our task is not found there either. Let's refresh this and just see what in the world is going on here. Let's open up our console. We'll do 1, task B, task not found. Okay, so everything's running good. We just need to figure out why in the world our task is not being found here. So let's go see what that's about. So we're getting error not found, and it's not found, which means it's being triggered right here. So it's returning this and it's populating that. So that means that it's checking this if statement, and if essentially this task weight doesn't exist, then it's returning this. So it's saying that it doesn't exist, which means that we need to come up here and look at this. Now our value, when it's coming over here, is from our task selection. So if we come up here and look at our, there it is. That's what we're missing right there, the underscore. So it's not registering it as task A, because task A, this, is not the same as that. Okay, so now let's save this and then try it again, and then we'll see what we got. Okay, I've refreshed it, so now let's pick 17, task A, get probability. Okay, here we go, good. So now we have a predicted probability for employee 17 at task A. Now remember this number, 51.09. So what we can do is we can come in here and like, well, that's a little bit low. After we did a whole bunch of studies, we realized that the weight of something else needs to be a little bit different. So we're looking at this technical competency here, and this is actually going to be 5, but behavioral, we don't want the, behavioral, we just need to update too, because we don't want the person having issues with, say, customer service or whatnot. So we'll also put that as 2. Now let's save this, and then you'll see how that modifies. So right now it is at 51.09. And then when we refresh it, we'll pick number 17 again. This is task A, and you'll see that it should change ever so slightly, 50.47. So you'll see that as you get more robust data and you're covering more and more variable and data points, that you can actually really fine tune this to reflect what would happen in your organization in your life. Now, again, this isn't something that you can just plug in there and say, okay, well, some guy on the internet told me that this is just going to work and we're going to be good, because that's not the intent of this. The intent is simply to just give you a basic working function to then build on. Ideally, this task A would have a lot more technical, behavioral, and even leadership competencies to include all the KSAOs that would be built on top of a more robust baseline here. But the intent is the same. We just need a little bit more data. So in the coming series, we are going to be creating that data, because we're going to be creating a career map. And in order to do a career map, we are going to need to grab all of these competencies and drill into their KSAOs in order to create that career map. It's not just taking a financial specialist and moving them up to a senior financial specialist or whatever the case may be, and just, coming up with some arbitrary things that they need to do that. It's really drilling into the competencies of what that person should possess, what the gap is in those competencies, and then what is needed to make them successful in that other particular role, in that new role. That's the concept behind a career map, and that's what this is going to do, and that's going to allow us to do this. And then when we get that done, we'll be able to incorporate that into our function here, and simply just adding them on right here, to the point to where we can then check the probability of success in that role or in that specific task, and get some sort of valid probability back that we can make an actionable decision on, and more importantly, defend if challenged. So I hope this was helpful. I'm actually really, really excited about this, because I'm curious to see how this is going to expand once we start building our competency map. But look for that series coming out if you're interested in that. We're essentially going to build it straight from scratch and take you through it, and then we'll incorporate this when the time comes. So thank you for your time. Hope it was enlightening and informative. And until next time, please take care.